All right, today we are on 3.7, writing linear equations. This first question is straight back from chemistry, so if you enjoyed chemistry and creating bonds, you probably like this problem. So alkalines are a type of molecule that has only one hydrogen and a carbon atom joined with a single bond. So for every one hydrogen, it just bonded once to a carbon. In the structural formula, these single bonds are shown by a line segment connecting a C with an H. The first straight chain alkalines are shown in the following table, starting with methane, the smallest alkaline. You don't need to know any of the molecule names. We're just exploring a little bit with the numbers side of it. So draw the structures for the rest of the alkalines in the table. Write the formula for each alkaline by first counting the number of carbon atoms and then counting the number of hydrogen atoms in the structural formula. Then write these numbers as subscripts. So instead of exponents, it's like the little number below the letter is a subscript on the element symbols. Finally, complete the ordered pair column by representing the number of carbon atoms and the number of hydrogen atoms as an ordered pair shown. So it'll, instead of X, Y, it'll be number of carbon, number of hydrogen. The first two alkalines are already done for us as an example. Okay, so methane, here's the structural formula for it. See, one carbon atom and then 4 hydrogen atoms surrounding it with a single bond. So we represent it as a chemical formula, CH, and then the subscript 4. There's no subscript for the 1 on the C because it's just an implied, just like when we have X, we don't write X to the first power. It's just implied that there's only one of the X's. And then the ordered pair will be 1, 4. Okay, going on to the next one, ethane. You don't need to know any of these molecule names, so don't worry about that part. Okay, so now we're adding another carbon atom in the middle. So we've got 2 carbon atoms, and then kind of on every single side, up, down, left, and right, there's something there. So if I'm looking at this 1C, right here, it's got hydrogen, 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 and then it's connected to the other C with a hydrogen, hydrogen, hydrogen. So we're going to count the carbons. There's 2 carbons, and then 1, 2, 3, 4, 5, 6 hydrogens. So the ordered pair is 2, 6. Next one is propane. They drew 3 carbons in the middle, all connected together, and then an H on each and every side of them. Again, each carbon has 4 lines attached to it. Hopefully you're able to see that pretty easily. So first we'll start with counting the carbons, 1, 2, 3, and then counting the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. So the chemical formula is C3H8, and then the ordered pair is going to be 3, 8. Okay, next one, for butane, we're going to have to draw it ourselves. Hopefully you're kind of seeing the pattern right now. I'm going to draw in the 4 carbons, and then a hydrogen on each and every side. Up, down, left, and right, there is going to be a dash on each of the C's. And then I'll count the number of C's. There's 4, and then there's 10 H's. So my ordered pair is 4, 10. And then for pentane, hopefully you can see the pattern. There's going to be 5 C's, and there's 12 H's. So the ordered pair is 5, 12. Hexane, there are 6 carbons, and 14 hydrogens. So then the ordered pair is 6, 14. And then the last one is heptane, which is 7 carbons. And then we draw hydrogens all around it. So we have 16 hydrogens. So 7, 16. All right. And then for the next part, complete the following chemistry formula for the nth alkaline by generalizing the pattern shown in the chemical formula column. So the chemical formula column is that third one over. I kind of drew it in for you. We're looking at carbon and hydrogen kind of separately. Like, what's the pattern going on here? So for carbon, we're just kind of adding one each time. So 1, 2, 3, 4, 5. But then how did we get hydrogen? Okay, so we've got 4, 6, 8, 10, 12. So each of these are definitely, they're going up by 2, but how can we tie that back into carbon? Because I'm generalizing the nth alkaline. So if I wanted to find the 15th alkaline, so when C is 15, I'm not going to keep drawing it out each and every time. Or the 100th alkaline, if that even exists. I have no idea. I'm not going to draw out a picture every single time or calculate by hand 4, 6, 8, 10, 12, 14, so on, all the way up to 100. That's going to take me forever. So to generalize that, since carbon is just adding 1 each time, the first alkaline is 1. The second alkaline is 2. N is going to be the number that we're using. That's the nth alkaline, and it ties right into 1, 2, 3, 4, 5, 6, so on. Okay, now how did I get from 1 to 4? That's the question. How did I get from 2 to 6 and 3 to 8 and 4 to 10? And if you kind of like math puzzles, you might catch on to this one pretty quickly. Notice that, okay, 1 to 4, I'm adding 3, and then 2 to 6, I'm adding 4, 3 to 8, I'm adding 5. That's not a consistent mathematical formula. I can't use that. Let's think about multiplication. Okay, so I can go 1 times 4 is 4, but 2 times 4 is not 6. Okay, what if I multiplied it by 2? Okay, so if I multiplied 1 by 2, I'd get 2. And I multiplied 2 by 2, I'd get 4. If I could add on another 2 to the end, I would complete my pattern. So 3 times 2 is 6, plus 2 is 8. 2 times 4 is 8, plus 2 is 10. 5 times 2 is 10, and plus 2 is 12. So that's going to be our generalized formula, 2n plus 2. So if I wanted to write a linear function to find the number of hydrogen atoms for a given number of carbons using the ordered pair in the ordered pair column, basically what I'm doing is I'm taking what we just did, but giving, instead of x and y, I'm kind of assigning variables to it. So hydrogen will be H, and the hydrogen depends on how many carbon atoms there are, okay? I couldn't figure out H without first knowing what C was. So it's going to be H equals 2C plus 2, which came from right here. Instead of N, I just used C. Interpret the slope and the y-intercept of this function. So my slope is 2 more hydrogen for each C. I multiplied my carbon by 2. That was my slope. I multiplied by 2, and then for my y-intercept, 2 H molecules without any carbon. Okay, so if there's 0 carbon, I'm still going to have 2 H molecules. That's like my starting point. Okay, and then question D, if a straight chain alkaline with 10 carbon atoms, how many hydrogen atoms does it have? If a straight chain alkaline has 10 hydrogen atoms, how many carbon atoms does it have? Is it possible to have a straight chain alkaline with an odd number of hydrogen atoms? Why or why not? Okay, so for this first one, if I had 10 carbon atoms, it'll just be, I'll use this formula here. 2 times 10 plus 2 equals my H, so H would be 22. And if I wanted to know how 10 hydrogen atoms, if I had 10 hydrogen atoms, how many carbon would I have? So I'd have 10 equals 2C plus 2. So I have 8 equals 2C. So C would be 4. Okay, so gotta erase all that works. The answer pops up. Okay, so 24 and 4 is what we had. Is it possible for us to have an odd number of H atoms? Okay, notice that I don't have any odd number hydrogens. It's always even. And so my answer is going to be no. The model says the number of hydrogen atoms is always twice the number of C. So anything times 2 is going to be an even number. And if I add 2, it's just still continuing that even number trend. So if you don't believe me, you can play around with some numbers and look at that yourself. Or you could just take my word for it. Okay, moving on. So we can always find, this next little part is talking about slope from a table. We can always find the slope of a function, a linear function, if we're given this table here. So what these like little arrows are doing is the difference in x, which is just like x1 minus x2 or x2 minus x1. And then the y's, same thing, difference in the y's, y1 minus y2. Okay, to find the slope m, we need to find how the y values change relative to the x values in this list of ordered pairs. The x value are always increasing by 2, and the y values are always increasing by 3. So my slope is going to be the y's over the x's, so 3 over 2. This constant rate of change confirms that the equation will be linear. So if I have this constant change, plus 3, plus 3, plus 3, plus 3, plus 2, plus 2, plus 2, plus 2, it'll always be constant. If you wanted to see the math, if you didn't really believe it, you can always do the formula y1 minus y2 over x1 minus x2. Plug in your numbers. So I plugged in y minus y, x minus x. I got negative 3 over negative 2, which is 3 over 2. So it works. Moving down to this next part. Number 3, write an equation for each line. If you want to go back and review these notes, you can. I'm just going to skip straight ahead, assuming that you know what you're doing. But if not, you can pause and go back. So we want to write the line that passes through the point 0, negative 8 with a slope of 4. So remember, a linear function is y equals mx plus b. M is your slope. B is your y-intercept. And we're given our y-intercept. We're given our slope. So all we have to do is plug it into y equals mx plus b. Nothing more than that. What if the line passes through the point 1, negative 8 and has a slope of 4? So this time we're given a slope, but we're not given the y-intercept. So we need to find the y-intercept. Again, we're going to use y equals mx plus b. We're given a y value, or we're given an x value, we're given a y value, and we're given the slope. The only thing we're not given is the b value. So I'm going to plug in everything I know. Y is negative 8, the slope is 4, and the x value is 1. So now I'll solve for b. So b is negative 12. Not done yet, because I still want the equation of the line. And remember, the equation of the line, we have our slope plugged in and we have our y-intercept plugged in. So I'm going to take those slope and the y-intercept value and plug it in. There's my linear function right there. Okay, now we're given 2 points. We want the line that passes through the point negative 8, 6 and negative 4, 4. So for this one, I'll need to use my slope formula, which is the difference of the y's over the difference of the x's. Doesn't matter which order you plug in your y's, so long as you keep it the same for the x's. Otherwise, your sign will change. So we have negative 2/4, which reduces to -1/2. That's my slope. I'm going to highlight it just like I did in the last one, so it kind of sticks out to me at the end, and I'm not searching through all of my work trying to figure out, oh, where was that answer again? So I'm going to highlight it right off the bat because I know that slope is important to me. And then from there, I'm going to do a similar approach to what we did in the last one. We're given a slope and we are given a point. We're given 2 points. So you can pick whichever point you want to use, either the -8, 6 or the -4, 4. It's totally up to you. I just picked -8 and 6 because it was the first one listed. So I'll plug in my x value, I'll plug in my y value, I'll plug in my slope, and I'm going to solve for b. Okay, so b is going to be 2. I'm also highlighting b because it's important. I need my slope, I need my y-intercept, and now I'm going to take those 2 values that I found and plug it into y equals mx plus b. Do I have us doing this last one? Yeah. Okay, then the last one, we still want to figure out that linear function equation, y equals mx plus b. This time we're not given anything except a table, so we're going to have to infer a lot of data from here. I know that we can find our slope using the difference of the x's and the difference of the y's, because slope, remember, is the difference of the y's over difference of the x's. So x is 0 to 1 is +1, 1 to 2 is +1, 2 to 3 is +1. Perfect. And same thing for the y's. I subtract 3 each time. All of my x's are changing at the same rate. All of my y's are changing at the same rate. So I know that this is a linear function. If for some reason this -3 was actually a -4, you could stop here and say this is not a linear function. But it is, so we're going to keep going. So my slope is going to be -3 over 1. I just plugged in my y value, the difference of my y's over the difference of my x's. And then from this table, thankfully, I'm able to see that my y-intercept is 5. When x equals 0, the y value is your y-intercept. So then I can plug in my slope and my y-intercept into y equals mx plus b. And there we go. And that's all I have for us for the classwork section. Make sure that you do the homework and that you're showing all of your work. Have a good one.